broadcast now.
The broadcast is now starting. All attendees are in listen-only mode.
Okay, good afternoon everybody and welcome to the September Alarm Corp webinar, CCTV Fundamentals, Optimizing DVR NVR Configuration. This is a re-recorded session for the benefit of those who joined us last time. As you know, we had some audio issues. Anyway, without much further ado, let's begin. My name is Piotr Torlecki. I am the National Product Manager for CCTV for Alarm Corp. First, a little bit of housekeeping. For those of you who haven't used the GoToMeeting before, you will see the menu tab on the right. Notice all of you will be muted for the duration of the webinar session. And now just to verify that you can all hear me, can you all please hit the raise hand button? Okay, great. I can see a few hands going up. If you can now put your hands down, we will continue. Finally, questions. You can ask questions at any time during the course of the webinar. Type in the question and remember to hit send at the end. Now the questions will be answered at the end of the webinar in the order that they are received, and just in case anybody is worried, only I can see the questions, so they are completely and they will be read out anonymously. So don't be shy. Please go ahead and ask any questions you may have, and don't forget to hit send as said previously. Okay, with that out of the way, let's begin. Today's webinar will cover the following: some terminology and concepts, continuous recording, motion recording, alarm event recording, auto-delete video grooming, searching for archiving video, and some additional comments and conclusions. And this is all in the context of optimizing DVR NVR configuration. So let's begin. First of all, let's just recap some basic concepts. Essentially, there are three options: DVR, NVR, and HVR. A DVR is what I'd call a classical digital video recorder. For an example, a TruVision TVR10. This records analog camera signals, so it's got B and C connectors on the back. You typically operate it via the front panel or a USB mouse in conjunction with a local monitor. And the encoding compression is done by the DVR, and storage is on one or more built-in hard disks. And there we have a picture of a typical DVR, in this case a TruVision TVR10. Next, let's look at a network video recorder, or an NVR. An NVR is something that records TCP IP streams only from IP cameras. And any operation/configuration is done either via a web client interface or remote client software. And typically, in the case of an NVR, the encoding/compression is done via the IP camera. The NVR receives the stream and records it to a built-in hard disk or more than one hard disk. Okay, next, hybrid video recorder, HVR, something like a TruVision TVR60 or a Verint EdgeVR 200. Now this is a combination. It records both TCP IP streams from IP cameras and analog cameras via the built-in BNC input on the back. So it records IP and analog camera simultaneously. Operation is typically via the USB mouse/front panel plus local monitor, but you can also operate it remotely via a web browser or a client software. And again, storage is normally done via the built-in hard disk. So there we have a picture of a TVR60 and a picture of a Verint EdgeVR 200. Okay. So now let's talk about recording options. The most familiar recording is what's called time-lapse recording or continuous recording. This is typically done on a 24/7 basis, but may be scheduled to be happening only during business hours. Now the main benefit of continuous recording is that there is continuous footage on the hard disk at the programmed recording rate. However, it does use up a lot of hard drive space to achieve a target retention time, and you are limited to searching via time and date. In other words, I want to go to time date X. Next, there is motion recording. Now, motion detection uses either the MD that's built into the DVR NVR or the camera, as is often the case with IP cameras, to trigger recording. Otherwise, the DVR is in standby. Now, motion detection can be problematic when used outside due to false triggering. And if it's not set up correctly, you may never record. Also, the footage on playback is discontinuous because you will have chunks of footage when the unit is recording and then when it's in standby. However, motion detection can work very well in many scenarios, and it's possible to search for specific events. And the main benefit is it can produce significant reductions in hard drive requirements. And finally, we have externally triggered recording, either event or alarm. Now, this is similar to motion, but the main difference is that now the trigger for recording is an external device. Now, this could be a motion detector, such as an EV735. It could be a read switch, or it could be point of sale or ATM transaction text, or even a HLI from an access control system. Okay, recording. How fast, how long, how big? The first question, has a recording rate been specified? Now, some applications, for example gaming, they mandate a rate. There's no room for movement. Other applications leave some freedom. Frame rate choice has a big impact on disk space needed and hence total system cost. Okay, the next question, what is to be recorded? What are we looking at? Is it a traffic situation? Is it a retail shop? Is it the checkout register? Is it a car park? Is it a petrol station? And the importance there is to understand the typical target speed, and by target we mean what are we actually recording. And then let's look at retention time. What retention time has been specified? Are we talking 30 days? Are we talking less? Are we talking more? This also has a big impact on disk space needed and hence system cost. And we will get into a little bit more exactly what we mean by system cost. Okay, image size. What resolution do I record at? Now, analog cameras are limited to 4CIF, which is 720 by 576 pixels. IP cameras can be anything from CIF, 2CIF, VGA, 4CIF, all the way up to 720p, Full HD 1080p, or even larger. Now, after the recording rate, this is the second biggest impact on the hard drive space needed. And just to put it into perspective, when you go from 4CIF to HD 720, you're effectively doubling or quadrupling even the number of pixels depending on the quality. Moment of truth. Storage calculators. Let's calculate how much storage we think we need. Now, nearly all manufacturers have storage calculations, and we see some examples on the following slides. Here we have the storage calculator for the Verint Nextiva system, and you see that in the bottom right-hand corner in the yellow tabs for the specified configuration with 31 days, 68 fixed cameras, 2 PTZs, and 5 spare inputs at the nominated recording rate of 12.5 images per second. For 31 days, we need about 14.6 terabytes. So this is one example of a storage calc. Next, we have a Verint Edge, which is for the Verint Edge Hybrid DVR. Again, similar figures. We have a storage calc for a TruVision NVR 20. And in this case, we see that we have an 8 terabyte unit with the specified cameras. We will get approximately 40 days of storage. And finally, we've got a TruVision TVR 60 calculator. So the key takeaway here is that most of the storage calculators are fairly similar. You specify typically the number of cameras, the number of storage days, and the recording rates, and at the end, you get a figure of how many terabytes you need. Now, the important thing about storage, all storage calculators, is that they are mathematically correct, but they cannot second guess the system design. They cannot tell you if the rate that you've chosen is actually correct for the application. Okay, so now let's look at optimizing configuration. Storage calculator shock. We've just plugged in the numbers and the storage result is way too high. Either it's beyond a chosen system's capacity. For example, our DVR is limited to 16 terabytes on board and we need 24 terabytes. Or it's outside the budget. In this example, we've allowed for 1 DVR, but because we think we need 24 terabytes, we'd actually need to buy 2. So what can we do? Or alternately, we already have a recorder on site that's not delivering the required retention time. The existing system is coming up short, and physical expansion may not be possible. And that could be for any number of reasons. Either the budget's not there, the system on site is already a year or two old and extension parts for it are not possible, or any other number of reasons. There's no space in the rack, for example. Again, so what can we do? Alternately, we have sufficient room, but we want better quality. We're finding that we are getting an image whose quality is not sufficient for the application. There are too many artifacts, the image is too low res. So again, what can we do? So first question is, how do I increase my retention time? So let's look at some of the options. The first option is adjusting frame rate. Is real time really needed? For example, if you drop from 25 images per second to 12.5 images per second, you will still provide very smooth playback, but you've just halved the storage time. Alternately, if this is too slow, will near real time be acceptable? If you drop from 25 images per second to say 17, 18, 20 images per second, you're still going to save between 20 and 25% of storage space. Now, if we're talking at the other end of the spectrum, at lower frame rates, if we record at 5 images per second versus 6 or 7 images per second, again, we're saving 25%. And that 25% might be enough to get you back in the ballpark. As always, check the suitability for application. Next, adjust bit rates or quality settings. For fixed cameras, reducing the bit rate or the quality can work well, particularly if this is a typical office retail scenario where we have very plain floors or very plain walls with very little detail. Next, we can look at variable bitrate if available on the system of choice. And this is discussed in the next slides. Finally, adjust resolution. Is 4SIF really needed on a classical DVR? Will 2SIF be acceptable? If we're talking about a megapixel camera, if we go down to 720p HD instead of full HD 1080p, will the image be still good enough? Now again, we need to check the suitability for application, but this may be the only viable option. Okay. Looking at it from the other perspective, how do I increase my retention time? We've looked at recording rates, we've looked at bit rates, we've looked at resolution. Now let's look at motion detection. Can I use motion detection instead of time-lapse? Even with 50% motion detection, which is very high, we either halve the storage requirements or we double the retention time. You should consider using a lower time-lapse rate with a few images per second with a higher motion detection rate. This is often quite a good compromise. Now, in practice, real motion detection rates are quite low on average over 24 hours, and we could be looking anywhere between 10 and 20% for a typical retail application. Now, again, some cameras, such as the checkout cameras, might be having much higher motion. But if you average it across a typical hardware store, for example, many cameras in some of the aisles will be lucky if they get a minute's worth of motion in an hour. So again, this can work quite well with fixed cameras. Can we use event or alarm triggered recording? As with motion detection, the intent is to record only when there's something happening. Now this is very useful for either point of sale or ATM scenarios, and with access control HLIs, for example, badging a door, granting or denying entry to somebody. Very useful for car parks or petrol stations, where you might have an inductive loop in the road, which triggers the boom gate, or you might have a switch on a roller door. And it's also very useful for retail and general office/warehouse environments, because often it's very easy to set up a trigger device in these scenarios. Now the key to success is correct pre- and post-event settings. Check that the pre and post are correct for the application. Now typically most DVRs will do between 5 and 10 seconds pre-event and a minute or more post-event. Now this will capture video either side of the trigger event, be it motion, ATM or HLI interface. Right. Now let's look a little bit more on motion detection and get some additional comments on getting it right. Check your grid or zones. Do not leave motion detection at default. Typically this is the whole screen. This will often cause false triggering. Pay attention to interference, flickering computer screens or reflections of these on shiny walls, movement in the background, swaying trees. If you're looking at a lobby scenario that's looking onto a road, if you've got any movement on the road behind the system, you might want to eliminate these trigger zones. Look at the target size setting where available. Now this is important because on some DVRs you can specify a minimum target size. What that means is that, say you've got a warehouse where you might have a resident cat. Now the cat maybe, if you set up your trigger zones to be large enough, the cat will not trigger the motion detection. However, a person walking through the system will. Check sensitivity and walk test, and be careful with outside cameras. They are trickier. Now here we have an example of a typical motion detection zone setup of a TruVision DVR, and you can see we typically specify motion detection by activating a certain number of squares. Now in almost all cases multiple patterns are possible. Okay, now what about outside cameras? Motion detection outside is challenging. There is a high potential for false triggering. Now you should always mask out any trees or bushes that can sway in the breeze. But another really good trick is to look at associated cameras. For example, let's say you want to record a delivery to a roller door, and you have an inside camera and an outside camera. But you're worried that because of your camera angle outside, it will always false trigger on the trees in the background. So what you can do is you can set up your motion detection only on the inside camera, and make the outside camera an associated camera. So what happens then is the truck pulls up to the roller door goes up. This is the event that triggers the motion detection on the inside camera, and by default that then also triggers the outside camera. Now because you've also set up your pre-event, you will actually have captured already the truck pulling up to the roller door. So that is one neat way of getting around motion detection for outside cameras. And finally, don't use motion detection on PTZ cameras that are on auto tool, because they will continuously trigger. Okay, now let's look at some of the benefits of motion detection and some things you may not be aware of. How does my DVR treat event or motion video? It may be possible to lock or tag motion/event video to prevent overwriting. Now this is useful for archiving incidents, e.g. suspicious persons in retail. What about video grooming? Some systems, for example Verint, Nextiva, Verint Edge, can groom the video. So what this means is that retention time for time-lapse video can be treated differently to event or alarm video. For example, time-lapse video can be overwritten in 7 days, but event video is kept for 30 days. So again, the key benefit is that you've got longer retention time for useful video. Okay, now let's look at the alternative. I have more space than I need. I want better image quality. So let's look at the options. The refresh rate is fine. I want more details. In this case, we want to increase the recorded resolution to falsive on an analog DVR. Now, check on some DVRs this may impact the refresh or recording rate. You can look at increasing the bit rate or quality level. On an IP megapixel camera, you can look at increasing resolution and quality. However, check the impact after a few days to ensure that the retention time is still okay. And with megapixel cameras, check if the higher resolution impacts channel count. On some DVRs this is the case, that when you increase resolution, you reduce the number of cameras that can be supported on a particular system. And of course, can your network handle the extra load? Higher frame rates. If your DVR, NVR or IP camera permits, increase the frame rate. If required, you can increase the frame rate on key cameras, but lower it on others. Now, this is a good option for speed-restricted recorders. And what we mean by key cameras, for example, if you've got a retail shop scenario, you might want to increase the frame rate on your point-of-sale and entry-exit cameras, but you may want to reduce it on, say, the camera that monitors some of the aisles. Again, after making adjustments, check that the retention time is still okay. Now, let's look at constant versus variable bitrate. CBR, VBR. Now, if you look at MJPEG compression, which was common up until a few years ago, this would use a full frame or an iframe for each image. This was not as efficient as H.264, but you had more consistent bandwidth requirements because the frame size didn't vary that much from one frame to another. Now with H.264 we have conditional refresh. We have complete iframes with smaller predictive frames in between. So what that means is that peak bandwidth can be much higher than the average bandwidth. Now constant bitrate attempts to smooth out the bandwidth by varying the compression at the expense of quality sometimes, whereas variable bitrate keeps the quality constant but allows the bandwidth to vary. So here is an illustration of constant versus variable bitrate. You see that on low motion, the bitrate drops in a VBR situation, but if you have high motion, the bitrate increases significantly. Whereas in constant bitrate, the bitrate remains more or less smooth. Okay, more detailed example. Here we have a situation where we have a constant bitrate system on the left and a variable bitrate on the right. Now if you look on the left, you will see that we have more artifacts in the image, but you will also see that the bitrate is typically staying between 0.38 and 0.67 kilobits per second with an average of around 0.52. Now in the variable bitrate scenario, you can see straight away that the image quality is a lot higher. But notice that the bitrate jumps up to over 1.1 and drops down to way below 0.37. So this is the trade-off that you sometimes have to make. And only the application that you're using it for will really be a good guide as to which is the better solution. Okay. We've talked about recording rates, we've talked about quality settings. Now let's talk about how green is my CCTV. And this is also in the context of total system cost. Some comments on the environmental footprint of any CCTV system. The initial purchase cost of the hardware plus the install cost are only part of the whole of life cost or total system cost. The power usage will be a significant part of the system cost over the system's lifetime. Now, optimizing DVR configuration can help reduce this. Let me explain. If you lower your total retention time requirements or total storage requirements, you need less hard drives, so we use less direct power. Now, also, if we have less hard drives in our system, we generate less heat. Therefore, we need less cooling or less indirect power. And also, a DVR that's recording on motion detection often idles the hard disks when they're not being used. Now, a hard disk that's idle uses a lot less power than a hard disk that's fully up and running and spinning. Conclusions. Optimizing DVR NVR configuration is always a bit of a compromise. We need to understand the limitations of the system that's being used, particularly if it's an existing system on site. Likewise, understand the limitations of the system that's been chosen if it's a new installation. We need to understand the application and hence impact of frames per second, resolution and quality. And this will be different for different applications. Take time to review any config changes after a few days and be prepared to make adjustments. And finally, understand any legal or prescribed recording conditions and work around them. Would you like to know more? More information, including brochures and datasheets, may be found on our website, www.alarmcorp.com.au. And I would really like to invite you to visit our website in the coming weeks because we are doing a major refresh at this point in time. If you haven't done so, register to the Alarm Corp Pulse to receive new product information automatically. Contact your nearest Alarm Corp representative, Jeff Rushton in New South Wales, Diane Brazil in New South Wales, Stephen Dinger in Victoria, SAOWA, and finally myself in Victoria on 0421 378 334. Future CCTV webinars. If you've enjoyed this webinar, stay tuned for more. There will be a CCTV webinar in October and also in November. Topics for this year will include the iPhone as a surveillance tool. So go to our website, click on the resources/webinars link, and you will find a list of coming webinars, and you will also find a list of previously recorded webinars that you can download and view at your leisure. We look forward to your participation. Now over to question time. Thank you.